All right, welcome back. I want to solve a volume problem, and I'm going to solve it in two ways. In this video, I'm going to solve it with the washer method. And so at the moment, we have the curve y equals x squared plus 1, and I've kind of indicated this region here. Let me shade it in. So this is going to be this shaded region, and so really I want the region bounded also with the y-axis, the x-axis, and the line x equals 2. So if I really take all four of these regions, I get the four sides of this shape. And so I'm going to get this kind of filled in region here. And I'm going to revolve that region around the y-axis. And so first I'm going to use the washer method. And as a reminder, the washer method uses strips that are perpendicular to the axis. So I'm going to draw in some of those strips here. And when I draw those strips in, and I revolve these strips, for instance, if I revolve this strip around the y-axis, it's going to give me a shape that looks something like this. It's going to be a washer. And so this washer is going to have an inner and an outer radius, and that's going to be something we're going to have to figure out. And so first of all, let's just set up our problem. So we're going to have a volume. So our volume is going to be the integral from where to where of something, and is it going to be dx or dy? Well, since our slices are going up, right, we have one slice for each y value, we're going to be integrating dy. And one thing that we notice here is that we have a different kind of behavior from y equals 0 to y equals 1 than we do from 1 up to 5. For instance, down here, until we get to 1, these strips all have the same length. Right? So this region, if we revolve it around the axis, is just going to give us a solid cylinder. So I'm going to kind of break this up into two different integrals, because it's going to help me. And so down here, I'm going to be getting disks of radius 2, right? I can just look at this and I can say, well, what's the distance of each of these strips when the y value is between 0 and 1? That distance is going to be 2. So this is just going to be pi times 2 squared, and that's going to give me the resulting volume of that first part. And then up here, when I move a little bit higher, now I'm going to be more concerned with, say, the inner and the outer radii. So maybe I'll do them in red and green. So if I draw in these sorts of things here, I can see that my, let's do the outer radius. The outer radius is still going to be 2. The outer radius is going to equal 2. And the inner radius is going to equal the x-coordinate on y equals x squared plus 1. So let's actually see if I can move this down here. So our inner radius is going to be the x-coordinates on this, so that's going to be equal to, let's see, we have y equals x squared plus 1. So if I solve for x, I get x equals the square root of y minus 1. Okay. And so this is my inner radius. My outer radius, we said earlier, is going to be equal to 2. So now if I put these ingredients here together, I'm going to get, let's see, pi times the outer radius squared minus pi times the inner radius squared, which is square root of y minus 1 squared. And now I'm just going to calculate this integral just so I can get an answer. Let's see what we get. You may want to pause the video and check and see if you get the same answer as me. So I'm going to integrate from 0 to 1 of, let's see, this is going to be just 4 pi dy plus the integral from 1 to 5 of 4 pi minus pi times y minus 1 dy. Clear this up. Don't need it anymore. And let's see, this is going to be 4 pi y evaluated from 1 to 0. This is going to be 4 pi y minus pi y squared over 2 plus pi y evaluated from 1 to 5. Here I did a little minor simplification. I expanded this before doing the antiderivative. And at the very end of the day, I'm going to get 4 pi plus, let's see, I'm going to get 20 pi minus 25 pi over 2 plus 5 pi. And then I need to subtract when I plug in 1. So I'm going to subtract 4 pi minus pi over 2. And then I'm going to add pi at the end. Right? So at the very, very end, I guess I didn't mean a y here, I meant a 1. So at the very end, I'm going to get 2 pi, let's see, if I combine all the pi's, I've got 4 and 20, that's 24, and 5 is 29. And then I'm going to subtract 4, that's 25. I'm going to subtract 1, so I think I get 24 pi. And then I still have these fractions. So I'm going to have minus 25 pi over 2 plus pi over 2. That's going to be 24 pi minus 25 halves plus 1 half. That's minus 24 halves. And so at the end of the day, I get 12 pi. Okay. So that's the volume of this resulting solid. And in the next video, I'm going to compute this using the shell method. And we'll see if we get the same answer. And you can compare which method you like better. So thanks for watching.